So with that, let me use the remainder of the time just working through the problem solving with the ChatGPT for this is something I've been doing for a while, and I do think this is one way in which generative AI can be really helpful in a way that my recorded videos could never be. And if I were to be helpful in a similar way, I can only be helpful that way in office hour. When you've come in, I'm looking at your solution and helping you real time. And most of the times, people are not coming into office hours, so that uh, using ChatGPT that way, it's like having a tutor at your fingertip who's super cheap. And I do think that's actually this interactivity can be really beneficial. So I do recommend it, using it in that way. And when you're using it in that way, I do recommend that you start out with a prompt that you've seen me use. So let me start out with a prompt again. Hi, I'm working on my mechanics homework again. We started the rigid body motion, including rotation this week, and I'd like your help in trying to understand the material again. Mind you, I have to be prepared to answer these materials in the oral exam with my professor, so please don't give me the whole answer right away. Lead me step by step so that I can understand and remember. And it'll acknowledge. So I have a little bit over 20 minutes. Let's pick out a couple substantive questions and work through them. This is probably not all that substantive. Um, this could be good. This was actually your, I think, pre-lab question when we had the what is it, circular motion lab. I think that's what this is, basically. I might come back today if I don't see something more interesting. Somersault. This could be good. In this sense. So I can imagine someone making this mistake. And this mistake comes from not noticing the units carefully. But let me try making the mistake and have a ChatGPT help me correct. I think that's the kind of the functionality I'm talking about. That lecture videos don't, because my lecture videos tell you what I've done to do the problem correctly, and from watching that, trying to figure out what you might have missed, that can be hard. So let me say, so I'm being given rotational kinetic energy. So let me call this kinetic energy rotational. And I'm being given moment of inertia. Let me call this I. So I feel like I know the expression for rotational kinetic energy, which is given by analogy to translational kinetic energy. 1/2 what's analogous to mass, I, rotational inertia, times what's analogous to velocity, angular velocity squared. So you solve this for angular velocity. Omega is equal to square root of 2 times rotational kinetic energy divided by I. And you plug in the numbers, you even convert, so let me plug in the numbers here. Omega is equal to square root of 2 times 120 joules divided by I, that's in basic SI units, 9 kilogram times meter squared. And you even work out the units and see that it's 1/second. And when you work this out, let me do it in a calculator. So 2 times 120 divided by 9. Can I do square root? I can do it by keyboard. Square root. So 5.164. 5.164 inverse second. and you plug in this answer, and you feel like you've done everything right. It should be right, and it says it's wrong. I knew I was gonna say it's wrong. So let's say you're in this situation, and you don't like this is a simple question. There isn't something you could have done wrong. So let me ask a ChatGPT. What did I do wrong? And let me see if it gets it. I don't know if it will. So I think this is a simple question, and I feel like I did everything right, but the system says it's wrong. What did I miss? Oops. Oh, yeah. Oh, I meant to paste this in. ChatGPT is pretty good about not hallucinating. So okay, sharing your work, yeah, formula, rearrange, yeah, yeah. So it's this is the challenging part. With the rotation, this angular, so it comes down to neither radian nor revolution are real units. So when you do dimensional analysis, unless you remember to put it in, it won't just pop up. And ChatGPT spots correctly that angular velocity is in radians per second, and where I didn't write radians, there is actually radian. And you have to convert from radian to revolution, even though neither of them are real units. So there's no real conversion. But one revolution is one cycle is 2 pi radians. So you do actually have to do that conversion. So so I guess the correction here would be I need to put in radian. So I'll be doing all right. 2 pi radian is equal to 1 revolution. Oops. So radians cancel, and I'll be left with a revolution. So I need to divide this number by 2 pi. Can't do that in my head, so let me, did I get rid of calculator? Let me do this. 5.164 divided by 2 divided by pi. So 0.822. 0.822, not radians, revolutions per second. Yeah, and I'm pretty sure that will be graded as correct. And this is really the utility of ChatGPT or generative AI, similar capability as ChatGPT, and using it like a tutor, something that can really check your work and give you context relevant feedback, like here. So here, let me say, yep, I got it. Thank you. Yeah. So again, yeah, this is a simple question, and but it's something simple like this can trip up people, and I think sometimes people get discouraged from that, and when you are able to interact with a virtual tutor, which is what I'm using ChatGPT as, you can get help on these really simple steps and get some reinforcement that you didn't know what you're doing. You just missed one simple thing. Yeah. That's good. All right, so let me look for other more substantive questions, ones that I won't miss. So with such this one, so I will tell you, a lot of people seem to do it in a way that I don't want you to. Although I wonder what. Let me see if I can come back to this. So if I have time, I can come back to this and obtain an answer by the superposition principle, and then ask ChatGPT, hey, I did it by superposition principle, but I want to learn how to do this. I could ask it that. So let me see if there are other questions that I'd rather do. So that looks simple. Simple. I mean, this is simple conservation of energy question. Let me look. This is a challenging question. So So should I work through this? All right, so let me do it this way. Let me do that other question first. Is it question 4? Yeah. Let me, because I think this I can do it in less than 10 minutes. And in whatever remaining time, let's attempt the question 9. So let me start with this one. So let me first quickly get the answers. I can do this through memorize the formulas. I know, have enough memorized. So rotational inertia about end. Rotational inertia of a rod about end is 1/3 L ml squared. That's the formula. So like I can get rotational inertia of this piece. It'll be I is equal to 1/3 mass of that piece, which I guess the whole thing being 2m, this being 1/3 of the piece, it must be 2/3 m mass, and the length of the thing L/3 squared. This is I1, and I can get I2 here as same thing, same formula, 1/3, but different numbers. Now it's 2/3 of 2m, so it will be 4/3 m times the length 2/3, so 2L/3 squared. So for I total, this is where I use the superposition principle. The entire object looks like 1 added to 2. So the total rotation inertia is also I1 plus I2, keeping the axis point the same. So let me just do the math quickly. On the denominator, it's 3 times 3 times 9, so 81. Numerator is 2 ml squared, that's this term, plus here same denominator, I think, 9 times 9, yeah, 81. Numerator now is 4 times 4, 16 ml squared. So the whole thing should be 18 over 81 ml squared, and I think I'm supposed to simplify them. They both have a common factor of 9, so it should be 2 over 9 ml squared. So suppose you got this answer, which will be graded as correct as it is, but let's imagine you do realize that it says by direct integration, and you realize you didn't do any integration. So let me paste this in and see if I can get help from ChatGPT. So I did this question my own way, and I don't think the method I used, superposition principle, is what they are looking for. What does the question want me to do? Let's see if we figure this out. Two segments, yeah, valid approach, direct integration. So yeah, set up and evaluate an integral. So set up an integral for the moment of inertia of a thin rod with a linear mass density lambda. Lambda is that, yeah, good. Integrate over the length with the axis there, good. General formula for moment of inertia, yeah. So when you are setting this up, so would you like to go through the setup of the integral step by step? Well, let's see. Let's see how well I can follow. The one limitation of ChatGPT is that it can't draw figures in a correct way. But let me see what I can do. So we are looking to do I is equal to r squared dm. And it has told us r is the distance from each small element dm to the axis. Right, so I guess I'm saying this axis, and dm is lambda dx, and r changes depending on the position along the rod. You'll integrate from 0 to L. So based on this explanation, here's a mistake that you could make. So the correct thing to do is to set x is equal to 0 and have an expression for r. say that r is equal to, or more precisely, I guess r squared is equal to, so if you are going to integrate from 0 to L, then I mean, I don't really want to integrate from 0 to L. I want to integrate from x is equal to minus L over. But actually, let me do it this way. I think the thing to do is let's define x is equal to 0 here. So x is equal to 0 here. Then you need to describe r as. So when x is equal to 0, your r should be L over 3. And when x is equal to L over 3, you want r to be 0. So you can kind of do a trial and error over some expressions, and what will work is something that looks like x minus L over 3 squared. Then at x equals 0, square it, you get L over 3 squared. Good. When x is equal to L over 3, you get 0 squared. And when x is equal to L, you get r squared is equal to 2L over 3 squared. So this is the consideration you should go through. But let's imagine that you didn't. You kind of set up the equivalence that's incorrect of something like x is equal to r. And you say I is equal to x squared lambda dx, and you integrate it from x equal to 0 to L. Let's see. Now, if I wanted to waste time, I could work it out, get an answer, and then see that it's wrong, and then complain to ChatGPT. But let me try asking ChatGPT now. So I'll say, yes, please. This is what I have so far based on what you said. So far, so good. Hopefully they'll spot the mistake. Let's see. Integrating r squared, correctly substitute, yeah, good, lambda. By the way, ChatGPT will usually be encouraging, so when it says this, don't assume that means everything is perfectly correct. It's very polite. Lambda in terms of, yeah, okay. And set up the integral with the limits around the axis at x equals L over 3. Yeah, since we are finding the momentum all around this. Okay, so that actually would work fine too. So yeah, if you did it this way, great, that'll work. Yeah, so you realize, okay, I gotta correct that. So I'll say, right, not this, but instead, not this. Instead, x will now run from L over 3 to 2L over 3. And we have x squared times 2m over L lambda dx. And you figure, okay, I can do this integral, simple power rule, x squared. So let me factor out the constants. That's 2m over L. The antiderivative of x squared is x to the third power divided by 3. You can kind of double check, take the derivative again, then you get, 3 comes down, cancels out 3 on the denominator, you get x squared on the numerator. And you evaluate this at the limit from minus L over 3 to 2L over 3. And because this is cubed, these signs will actually matter. You will get 2m over L times, plugging the upper limit, so 2 to the third power is 8, L to the third power divided by 3 to the third power, 27 times 3 in the denominator, 81. And then it's minus what you get by plugging in the lower limit, which would be minus L to the third power divided by 3 to the third power times 3, so 81. 2 minus signs cancel, so now it's plus. So you get 1 factor of L canceling. So you have 2 here, and And yeah, I think the rest can simplify, but let's ask ChatGPT how this looks. And it should say it looks correct. How does this look? Yeah, correct, etc., etc., etc. I was basically copying, and then it says final answer simplify. So you can verify that 8 plus 1 9. So in here it's gonna become 1 over 9 L squared. So you got 2 here, so 2 over 9. Yeah. Great. Thank you. So yeah, it's pretty good. You can spot when you've done things differently from the instructions, and you can kind of walk you through that. I guess the one thing that it's missing is the when you see me do it, you will usually see me break this up into little pieces. Like imagine when this is what the kind of the mental image you should always have whenever you are going through anything that requires like integration. Imagine having broken up the thing into many tiny pieces, and then you are considering a representative element and what is the rotational inertia due to the representative element. Um, so, like this is R and so on. So that's the kind of consideration I want you to go through. But the word description of ChatGPT does have enough detail. You can kind of try to fill in the gap yourself. All right, we got a few minutes left. So let's get started on the question 9. And we probably won't be able to finish it, especially with me thinking of ways to mess up. But but let's see how far we can get in like 3 minutes. They say this is a difficult question. Where do I start? So the thing that makes this challenging is you have to manage two conservation laws: conservation of momentum, linear momentum, and conservation of angular momentum. And I think let's see, hanging vertically. Maybe it's not that hard. So actually, sorry, it has conservation of angular momentum, but not conservation of linear momentum. Because like a hanging part will make it so that there's some pivot force that'll make it, yeah. So ChatGPT should identify that you are going to be using conservation of angular momentum for the collision, and then the conservation of energy for the swing up part. So yeah, and that's what all the hints, yeah, what conservation laws apply. Those two in different distinct parts. It's almost like a ballistic pendulum, but it involves rigid body rotation. What is the rotation? Yeah, that you gotta look it up or remember 1/3 ml squared. Yeah, central. Yeah, so maybe it's all the little pieces that you need to consider that makes it challenging. So rotational dynamics and energy conservation. Yeah, collision using angular momentum. Yeah, inelastic collision, so no energy conservation at the collision. And because there are no external torques, yeah, no. Let me ask, what about linear momentum? Isn't it conserved? If you are asking it, then it should say that it's not conserved because stick is pivoted, and in that pivot force is where there can be enough external force to change its momentum. So yeah, it has a setup. That looks good. Yeah, when you have it, we can move on. So I'll say, all right, I gotta go soon, and look at the angular momentum conservation steps in detail. can you tell me about because it said um, energy conservation concepts? Because it only did worked through the angular momentum conservation and didn't do the energy. Yeah. And it will probably give those steps. Found omega, and then yeah, so it doesn't give omega directly because of the prompt that we gave before. It'll wait for me to calculate it, but it's giving me what to do in the next steps. Immediately after collision, you got rotational kinetic energy. As it swings up, you have potential energy. You set this up, and so yeah. So let me do this. I'll say one of the hints say something about. Can I? So let's do it this way. One of the hints say this. What's this about? And have ChatGPT explain it in even more detail. Guiding you how to calculate based on change of its center of mass, and you should have you consider center of mass of due to the stick and the bug. Now, yeah, mass of the stick is 10 times the bug. It's probably not. Bug is heavy enough that you shouldn't ignore it entirely. Its center of mass rises to a higher position. Yeah, you should calculate the vertical distance center of mass from height from the end of where the bug is. Focus on the center of the stick. Yeah, and change in height. So what contributes to the? And I guess this is the questions to clarify. And I should consider change of gravitational potential energy of the bug separately. Like if you forget to do that, that could result in an error that's big enough to grade it as not correct. Yeah, bug is at the end of the stick, so it'll have its own change in height that'll be different from the change in height of the center of the stick. Yeah, good. So I think that's enough. Again, it's a system of how you might be able to use something like a ChatGPT as a virtual tutor. And sorry, today's session's a little bit short because of the derivation I had to do at the beginning, but I do think this has a potential to actually help you as opposed to Chegg tutors who can't really respond in real time like generative AI can. And a lot of times people just end up misusing those resources by just, copying the answers. And it's hard to look at someone else's solution and understand it in one shot. Like you do really want to be able to ask questions back so that you can check if you understood it correctly or be corrected if you misunderstood something. So, all right, that's everything. Thank you so much to those of you joining this virtual class session by recorded video. I will see you next week.